All right, so I'm James Sweeney. I'm from Northern Star Resources. So Northern Star Resources is a global scale Australian gold company with projects mostly in Australia, but also a flagship North American operation in Alaska. So the Pogo mine itself is located about 220 kilometers by road from Fairbanks, or we're in the United States, so about 140 miles. And it's been in operation since about 2006, Pogo mine, but Northern Star Operations took over in 2018. And I'll pass over to Dan for Mipac.
So yeah, Mipac is an engineering services company based in Brisbane, Australia. It mainly specialise in control systems, data historians, but we also have a software development team. We're a Aveva partner with PI accredited engineers. Now I'll go back to James, if it works, for the background.
There we go. All right, so yeah, I'll go over a bit of a background of the operation first and then talk more about the business case for going through the digitalisation process, as well as what challenges we faced and what we wanted out of the digitalisation. I'll pass over to Dan after that for the more technical and difficult stuff. So Pogo Mine is, as I mentioned before, is located about 140 miles from Fairbanks, Alaska. You can see on the right-hand side of the slide there, that little gold star, that is where we're located. So really in the middle of nowhere. Nice little picture on the left of the processing plant. So since production commenced in 2006, we've produced over 4 million ounces. And once it was acquired by Northern Star Resources, there was a lot of work put into expansion projects where we took the operation from 1 million tonnes per annum to a current 1.3 million tonnes per annum. So log sheets, what do we use them for? So we have three main reasons for using log sheets. The first one is tracking, monitoring, and acquiring data that we don't have instrumentation for. So there's a lot of streams where either the pipe work or something like that isn't suitable to put a density gauge, for example, on there, so we need to take manual checks from the operators and record them. The second main reason is to verify the instrumentation that we do have. So as everyone knows, instrumentation fails over time, it drifts, and those readings are no longer accurate after a period. So having these log sheets, we can get manual checks of densities, flow rates, and things like that, so that we can pick up when that instrumentation is off and have it either calibrated or changed out. The third reason is for the process operators themselves, ensuring that they are keeping track of our key process variables, making sure that they're within our operating targets, and just making sure there's eyes on that as well. So at the moment, or previously, we had 10 separate log sheets required. They're all Excel-based. That picture is an example of it. And every single cell was a manual data entry point before we used VBA macros to upload it onto an Excel-based database. This is a quick overview of our process flow. I won't go into the details, but essentially lots of different unit operations in a very small plant. So we have about 10 different areas, each of them having 1 to 2 log sheets a piece. And so as you can see, lots of data entry, lots of different spreadsheets floating around, and definitely some challenges involved with all of that. So each of these colors is a different area of the plant as we've allocated it. So the business case. I'm sure everyone's seen some sort of similar errors to this with their Excel spreadsheets over time. I had a lot more than that, but these were my favorites. Catastrophic failure, that one was good. Damage to the file was so extensive that we couldn't repair it. So this is the type of thing we would face on an almost daily basis with the sheer number of Excel spreadsheets we had. different operators with different accounts and everything like that. It really just caused a lot of headaches. So it was very time consuming for the operators, not only because of these errors, but with different accounts, logging on, read only, and the likes for that. So both operators and the metallurgists were spending a lot of time either fixing or sorting out issues with these sheets. The security, so everyone knows that data security is becoming more and more important these days. So we had a period where we were using shared accounts that got converted to everyone having their own separate accounts. And as we know, people forget passwords, people use other people's accounts anyway, and that was still a major issue there. So another big one was the Pi uploads from these sheets were confined to 24-hour periods. And so there was a lot of data lag for the metallurgists who actually go through the data and analyze it. We were confining it to 24-hour periods and using averages over that time, so there just wasn't much granularity in the data. So what was the solution? So in conjunction with MPA, we were looking to basically digitize the log sheets. So that was leveraging the existing plant data in the Aveva Pi system and configuring the log sheets as similar as they were in Excel, but on the web-based program using PyAF. So all the data was to be web-based as opposed to using Excel spreadsheets. And essentially, we wanted to organize the data so it was entered at the timestamps that we specified, which coincided with the operator's rounds. And one thing that we were really interested in was having that real-time Pi data upload. So as soon as the data was collected and entered by the operator, we would see it on Pi, and we would know exactly what was happening at the time rather than the day after. So the benefits of making this change was the data visualization. So much easier to visualize and see the data on a real-time basis rather than looking up Excel spreadsheets and going to Excel database systems. There was also a single source of truth with using this software. So with Excel spreadsheets, it's very possible to get multiple copies of spreadsheets. They might have different operating targets. They might have the old targets, and we've changed them, but it really gets a little bit confusing that way. So this ensured that everything was the same. And as mentioned before, having that plant data readily accessible to view and share to a wider audience at all times. And now I'll pass over to Dan, who'll talk about the architecture.
Thanks, James. So I'll give an overview a bit about the architecture and how it's sort of implemented. Before I go into an overview of the architecture, basically give you guys a bit of an idea which software sort of was used. So MPA is a bit of software that MPA developed, and it's mainly used for the visualization and basically data entry into the Pi system. So it interfaces to the Pi system through the AFSDK. So this is a basic overview of how the architecture sort of looks like. Basically, we've got on the right-hand side, we've got the METs and the operators entering data via web-based log sheets into an MPA web server into the Pi system. And once combined, that data comes out via Pi Vision on web-based Pi Vision displays. So to zoom in a little bit on what it sort of looks like, as I mentioned before, it uses the AFSDK to basically extract, read and write data. There is a workflow engine that transforms the data, performs additional calculations if required, and there's a front-end web server where you can do conditional formatting and also a bit of data validation through the conditional formatting onto a web-based log sheet. So on the implementation, so we worked closely with Northern Star Resources to implement basically these web-based log sheets and reports. The log sheets using MPA for data entry and the reports or other visualizations using Pi Vision. So we sort of used an iterative sort of approach We've developed some simple log sheets to give people a look and feel, and then the Mets would have a look and then show it to the operators as well. And then once you actually see something, you tend to have new ideas or want to go in a different direction or change your mind even. So it did take a little bit longer than expected to sort of go through that, but it was sort of worthwhile in the end, because when we got to the user acceptance testing and then going through operation readiness, handover sort of thing, that was very smooth. So some pictures to show roughly what it sort of looked like. We had a new AF database here with each AF element corresponding to a log sheet. And here is an example of the MPA sort of workflow where it uses the AFSDK to pull data out and uses the metadata that's present in PyAF to combine and massage the data. And then basically the front-end web-based log sheet looks something like that. So this is a more zoomed out, bigger picture view of the MPA and log sheets. So on the left-hand side, you see here, sorry for people on the other side, but you see the AF hierarchy from that specific log sheet database. There's also a time selector on the top right, where you can define basically your shifts or your days, basically your day start time, your shift start time, whether it starts at 5 a.m., 6 a.m., 7 a.m., and then you can scroll back and forwards through the day that you need to enter the data for. And as James mentioned before, for the data entry, you can specify almost blank rows at specific timestamps, where when you go into a day which corresponds to the operator's rounds, where you have placeholder rows there already, so you don't have to add a new line, add a new timestamp and value pair to enter a new row. They have placeholders there for you to help you enter that data. So as mentioned before, the AF templates were used to facilitate the log sheets. So we can base MPA templates on top, leveraging the AF templates that's there already. And we also used attribute categories. So basically that's another set of metadata that gets pulled in. So some of the things we use it for with similar sort of templates, but you can have different sorts of attributes. So it's used to filter for attributes to display on a log sheet. Also with different value retrieval methods. So sort of like you can assign it to a category that's pulling the value at the start time of the time period, like opening inventory at the end, closing inventory. And with the same attribute, you can give it another category to say event weighted sum, like production or something over the time period. Here is another one, picture of a digital log sheet. The only thing I'll probably point out, or specifically over here, is in collaboration with basically Northern Star, we've added some new features while we were developing the software to say, give you warnings in case you selected the wrong date. So when you go back in time, you're not selecting the current date, it'll give you a warning to say, are you sure you want to enter the data at this time? And then we basically also have targets, which are dynamic, and in this case, placeholder columns of the different timestamps that where you enter data. There's also conditional formatting that sits on top of the log sheets. So as you know, like data integrity, data quality is very important. You save a lot of time later on. Basically, this is like at the sort of entry level where you can, low-hanging fruit, where you can sort of prevent some of those errors in data entry with conditional formatting. So once you look at the log sheet, once you've entered it, it should highlight the things that are outside of the target or outside of a deadband. So I guess if you're in a hurry, you enter the wrong number. If you had this on an iPad, we have capacity touch gloves with safety glasses and hurrying somewhere else, you could enter the wrong data, put an extra 0, but the conditional highlighting will format or will highlight that for you to take another look, so it's easy to identify. So next I'll hand back to James to talk about the visualization in PyVision.
Thank you. So we've included a couple of examples here on how once the data is entered, how we use it and how it's useful for us on a real-time basis. So all of the data that's uploaded onto Pi from the log sheets, we have vision pages set up to analyze that data. This one in particular is my favorite use for the vision sheets. So this page itself is actually given to our instrumentation and electrical team, so their supervisors have access and will actually monitor this page on a daily basis. You can see on all the different charts we have dots and lines. The lines are what the instrument is reading, and the dots are the data that was entered through our Mipac log sheets. So essentially for each of these, the dots can be seen as hand checks, so using their own instrumentation to compare against the online instrumentation. And by having this, it's very easy to pick up when instrumentation is drifting or reading wrong. So for this particular example, you can see this density gauge is reading quite accurately and performing well, as with this pH. But you can see down here our density gauge for the flotation con was drifting, and it was quite, my apologies, there we go. It's quite different to what the hand checks with the Marcy scale were reading. So in this case, the metallurgist or the instrumentation supervisor would pick this up and say, we need to calibrate this instrumentation. So we've really started to be able to pick up things or issues a lot quicker than previous, when it might take days to have enough data to actually be able to know for sure if instrumentation is off. Another example here is, so previously when we were using the Excel-based log sheets, we would have average of checks every 24 hours, 12 to 24 hours depending on the variable. And these dots here are all of the hand checks. This is a dissolved oxygen reading. And then as soon as we started using the Mipac digitalized log sheets, we were able to get that data every 2 hours instead, so each round from the operators. And it was very obvious. We could see that within these periods there was a lot of trending up and down within that time, so the data granularity is much better. And so as a quick summary, we had a challenge, Excel-based log sheets. It was very resource and time intensive using Excel, and experienced a lot of issues and different sources of truth. So the solution was to deploy the latest Aveva Pi system technology using PyAF to integrate the processed data and manually entered data. And we deployed Mipac's MPA software to leverage that system and provide a front end for the data entry. The benefits that we had improved consistency and reliability of data. We had a lot more improved efficiency from data entry to analysis, and integrated systems as well. I was going to try and quantify this and include a percentage time saving, but I couldn't quite get a % of 0 because we're no longer spending any time maintaining this system. And that is it for that. So thank you everyone for listening, and if there's any questions, we'll be happy to answer.
Just wait for a microphone so that everybody hears.
Hello. This is Jesse Karkek from Guardian Glass. Got a quick question about error proofing and how it handles, say an operator does put in a wrong entry. Is there a way to edit it and correct the original point, or does it duplicate the point when you go back in?
So you can basically go back in and edit the same point, but then you lose the history of what it was before. Okay. Yeah. So similar, because everything's been stored in a Pi point, so you might have the annotation of it's edited, but you wouldn't have the previous value.
One other quick question. Do you have any way of tracking comments from operators, not necessarily in PyPoints, but as part of the system?
Yep, so we do it in a few ways. So it's either we can create event frames like for every shift, and then you enter a bunch of comments into that event frame, or it can be stored in PyPoints as a string as well.
Okay, thank you.
Your worst enemy, David Carr from Oceana Gold. Question for each of you. Have you found this is something you can then easily implement across the group to your other operations to use the same method? And with the AFSDK, have you found a way of being able to easily track which operator ID entered the round, so you know if you've got an outlier point, is there an issue with how they're taking the measurement, because you can track down who it was on that shift that entered the result?
I'll answer the first one, but sorry, could you clarify like different operations? Do you mean upstream, downstream mine, or just
more towards Kalgoorlie and your other operations? Is this a group standard you're pushing to be able to roll this out now elsewhere if you've got high at the other sites, so that you're using the same methodology everywhere from the investment?
So I do believe that the other sites are looking to bring in some digital optimization and standardize the templates across sites. So yeah, to answer your question, yes, it is something that we can bring around the other sites in operation. There is site differences, obviously, between the sites with how we operate our paste in particular, which is very different from here to the Australian sites, but on the most part, it is quite easy to standardize everything, and that's the plan. Yeah. I'll let Dan tackle the second one. Yeah.
Cool. I guess in terms of the other question, we don't have anything in place to sort of track who's making those changes or which crew is entering the data. But for some of the other places that do use MPA, we've applied different sort of methods where it's sort of like ideas about trying to prevent, like you said, tracking who it is, but also maybe preventing other people from messing with other crews' data entry. So you can sort of apply a different, if you have an enterprise agreement or an unlimited PyTags, different set of PyTags with different set of permissions for different crews to sort of enter that way, and through authentication with Kerberos.
Any other questions?
Andy Alehoff of Tech Systems. How hard is it to add a new log sheet to your system? Is it, I mean, can the end user do it, or do they need to go back to you to have them redesign a new? So if I needed to add a new log sheet, right, or I was trying to digitize something else, how hard is it to get that digitized, or is it very quick, or is it something the end user could do, or does the programmer need to do it?
Depends if it's a similar type. So if it's a similar type, because it uses the AF template, so as long as those templates have been created, if you just create the new template in AF, it's quite easy. But if you want a different type of log sheet, it's not as easy at the moment, so you'll need someone to go in and have a look. But I guess with the workflows, the software team are currently working on it, trying to make it more intuitive. But yeah.
And just to add to that, there have been a number of changes or modifications that we have needed to make after the fact, whether it's just something new that we wanted to monitor or that we overlooked originally, and the Met team has been able to make the minor modifications themselves as well. So yeah, definitely pretty user-friendly that way.
Thank you. Other questions? No? Oh, well, we're time out. Okay, great. So thanks, guys. It was very good.